Here is a riddle that sounds impossible until you see the trick. A hunter leaves his camp. He walks exactly 1 kilometer due south, then 1 kilometer due east, then 1 kilometer due north, and he finds himself standing right back at his camp. Then he spots a bear. The question is not where the bear is. The question is, what color is that bear? Pause here and think about how that walk could ever bring him home. First, why is this so strange? On flat, level ground, walking south, then east, then north, does not bring you back. You end up 1 kilometer off to the side, staring at empty snow. The whole secret is that the Earth is not a flat sheet. It is a ball. And on the surface of a ball, directions and distances play by different rules. Start at the very top of the world, the North Pole. From the pole, every direction points south. So the first kilometer carries him straight down, away from the pole. The second kilometer heads east, but this close to the pole, going east simply curves him around in a little circle around the top of the globe. The third kilometer points north again, straight back up to the pole, the exact spot he started from. The square path closes, but only because the ground curved beneath his feet. So the hunter must be standing at the North Pole. And the only bears that roam the ice around the North Pole are polar bears. Polar bears are white, so the bear is white. There is a sneaky twist. Near the South Pole, there are also special rings where a south, east, north walk loops back. But no bears live in Antarctica, so the classic answer stays white. Let's go deeper. On a flat page, the 3 angles of a triangle add to 180 degrees. On a sphere, they add to 180 plus an extra term, e, called the spherical excess. And e is not arbitrary. In radians, it equals the area the triangle encloses divided by the radius of the sphere squared. Our walker turns a right angle at the pole and a right angle at each corner below, 3 right angles, which sum to 270 degrees. So the excess is exactly 90 degrees, and that 90 is a direct measure of how much of the globe's surface the little square wrapped around. This riddle is really a doorway into deep mathematics. For 2,000 years, people assumed geometry worked like a flat page, following rules written down by Euclid in ancient Greece. But in the 1800s, mathematicians like Carl Friedrich Gauss and Bernhard Riemann showed that curved surfaces have their own geometry, where a triangle's angles can add up to more than a flat one's. They called it non-Euclidean geometry. And that very idea, that space itself can bend, is what Albert Einstein used to describe gravity. A simple bear riddle shares its DNA with the shape of the universe. If you enjoyed this, follow Theovis for more puzzles fully explained.